Hey guys, welcome to another exciting time in the Maths Club. Just like we discussed in the previous video, we are going to be working with the WAEC syllabus. And if I go to the WAEC syllabus briefly, you'll see that the first topic, right, is number and numeration. And under number and numeration, the first subtopic that we're going to really be treating is the number bases, right? So that is going to inform what we're going to actually treat today in today's session. Hang in there for an exciting time. So let's get started. Right, number and numeration. As always, we are going to always be beginning with the course objective. Why are we doing what we're doing? So according to WAEC, right, we have our aims, right? Mathematical competency and computational skills, understanding of mathematical concepts and their relationship, ability to translate problems into mathematical languages and solve them using appropriate methods, mathematical competency and computational skills, logical, abstract, and precise thinking. These are all the things that WAEC wants to test each student on. Now, back to what we're going to do for this particular topic, right? We are talking about number bases, but for today's session, we're going to really limit it to introduction to number bases, right? But in subsequent sessions, we are going to be converting from one base to another, and basic operations, adding in one base, subtracting in one base, multiplying in one base, right? So let's get started. Number bases. Now, when you hear number bases, you always want to know what exactly are we doing or are we saying, right? So, look at the fingers, right? When you count number 1, like number 2, number 3, number 4, number 5, right? You're counting numbers, right? Just like when you want to go to the market to buy oranges, right? Your mom says, take this money, go to the market, buy me 5 oranges. You go to the market, the fruit seller, you pick one. Number 1, number 2, number 3, number 4, number 5. You are counting, right? Maybe knowingly or unknowingly, you're actually counting in a particular base. What base are we counting in? You guess right. Base 10. Right, so when we count numbers, right, we're counting in base 10. Now, so there are different types of bases, right? I've mentioned one already, which is base 10, but beyond base 10, there are different diverse numbers of bases, right? So let's kickstart. The first one is binary base 2. I'm sure this is very, very familiar. People that I've worked with zeros and ones, probably you've worked with zeros and ones in prior courses, maybe in your junior secondary school, right? So you've seen zeros and one. Now, what is characteristic about base 2 is that it only contains 2 numbers, 0 and 1. And let me teach you a trick. Whenever you're working with base, if you say base 2, right, you notice that every number base 2 will contain, this is actually correct up to base 10, right? So if you're working on base 2, you will have numbers from 0 up to 1. It's not include number 2, right? So if you're working base 2, you have number 0 and number 1. That means anything that, if you say number, so let me give an example. So if you say base 2, right, you will see numbers like 1, 0, 1, 1, 1, right? You notice something, that the highest number that you see is always 1 less than the base. Remember, we are working in base what? Base 2, right? The highest number that you see in base 2 is like 2 minus 1, which is what? 1. So the highest number that you see in base 2 is actually 1, right? So if you're working in base 2, you'll be seeing numbers from 0 and what? And 1. Great. Now, that is binary. The next type of numbers we'll talk about is the ternary. Ternary is base 3. Just like my explanation for the previous one, the highest number that you're going to see in a ternary base is going to be 1 less than the base number. And 3 minus 1 is what? You guess right, 2. Right? So you're going to be seeing numbers from 0 up to what? Up to 2. So a classic example of a base 3 number, you'll be seeing probably something like maybe 2, 0, 1, right? in base 3, right? So you can see numbers like this, but you will never see a number 301 in base 3 because of what? The highest number of a base 3 should be one less than that number, in this case, which is what? Our number 2. Great. So let's forge on. We've talked about binary, we've talked about ternary, right? The next type of base that we have is quaternary. Quarter is like 1/4, right? So quaternary is base 4. Just like my explanation before, the highest number that you see in base 4 is number what? You guessed right. Number what? Number 3. I mean, we are all on a row. So you see number 0, number 1, number 2, number 3, but you won't find number 4 upwards in a quaternary base. The fifth type of base that we have is the quinary. Remember, these names are actually, you'll never really see mass asking you or like asking you what is the name of base 3. I mean, these are good to know, right? But they're not necessary that you actually know them. So in base 5, the highest number that you see is one less, which is what? 4. So you'll be seeing numbers from 0, 1, 2, 3, and 4. Great. Same thing too for ternary, which is base 6. For septenary, which is base 7, right? We have octal, right? I'm sure you must have heard of octal, right? Octal. So octal will contain numbers from 0 up to what? You guessed right once again. I mean, we can all applaud ourselves. We're actually doing very well, right? So from 0 to what? 7. Great. And you see nonary from 0 to what? To 8. And then our decimal number, which is what? Base what? Base 10. Base 10 is the number that we know, right? Base 10. And you can see from 0 up to what? Up to 9. And one interesting thing about base 10 numbers is that, I mean, you could say something, but in school, whenever I want to solve, right? When I'm counting, I'll say 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, maybe we start from 1, right? We're not computer scientists. Computer programmers are the ones that really start from 0. But that's another story for another day, right? We start from 1, 2, 3, 4, 5, 6, 7, 8, 9. They will say 10. How come the decimal numbers, which are our counting numbers, end at 9? I don't even understand what I'm saying. We are counting 9, when we want to count to say 10, 11, 12, but the counting numbers, which is basically the decimal, ends at what? Number 9. Let me show you what we actually do when we actually do counting in that nature. So whenever you do counting, right, you say 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your normal counting numbers, which is your decimal numbers, right? Then you now continue, you say 10. Do you know that actually you're just repeating the whole circle again? And this is the interesting thing, right? 0, 1, 2, 3, 4, 5, all the way down to number 9. All you're just doing is that you're just adding a number behind your normal decimal range. In this case, you'll be adding 1, 1, 1, 1, 1, 1, 1. So same thing too, when you reach 1, you're going to number 20. It's still 0, 1, 2, up until number 9. The only difference is that you're repeating the same thing. The only difference is that you're just adding a number behind it. In this case, 20, 21, 22, on and on and on. That's up to what? 29. So our counting numbers, basically in the base of everything, like when you break it down to the smallest units, right? What scientists or chemists, right, they'll call in the atom of everything, right? You have number 0 to what? Number 9. Every other thing that you see here are just modifications of number 0 to number what? To number 9. Are we good? Are we good? So let's push on. Great. So we've talked about decimal, which is our normal counting, right? So we have undecimal. Now, if you look at it, you're seeing something very special, which is what? You got it, right? The number what? Number A, right? Why do you think we have a number A? Remember I told you something. The building block of all numbers is from 0 to 9. Now, we have base 11, right? I told you the highest number should be one less than that number. In this case, that should be what? That should be 10. Right, so I mean our number should be 0 to 10, but 10 is not. If you look at the base the fundamental numbers that we have. 10 is not a fundamental number. Just like in this case, 10 is just a modification of 0 to 9. So to be able to now say, oh, we still need one more thing after number 9, right? They now switch to what? Alphabetical numbers, right? So you see that, oh, after our number 0 to 9, there is still one more, right? To represent that one more, they started using what? Alphabets. In this case, capital letter what? A. So if I go to base 12, do you want to guess what's the last number in base 12 will be? Let's see if you got it right. Now look at this. This is duodecimal, which is base 12. You can see the last number is what? Is B. So if you got it right, you can actually applaud yourself, right? You're actually doing very well, right? So you can see the last number, just like after we got the number 9, we said, right, we needed a space for 2 more numbers, right? Because the highest value here should be of the form 11, right? But 11 in itself is not one of the fundamental numbers that we have, right? Remember, so let me even relate it to ABCD, right? The fundamental numbers, the fundamental alphabets we have are A to Z. Your name, maybe your name is Joanna, right? It's just a combination of all those basic numbers. So the big alphabet J, alphabet O, alphabet A, alphabet N, alphabet N, alphabet A. Same thing too. The building block numbers that we have are just what? 0 to what? 0 to 9, right? Every other thing that you see is just a modification of what we already have. Great. So we are all doing well. Now, if that is the case, so same thing too for hexadecimal. I'm sure you've heard of hexadecimal base 16. After we reach number 9, right, we still need how many digits? We need 6 more digits to represent what? Base 16, right? Base 16. So you can see that's why we add what? A, B, C, D, E, F, and what? And that's all, right? A, B, C, D, E, F, right? So these are some of the things that we are going to really be putting into consideration when we are dealing with what? Base. And one other thing that you notice is that when we're dealing with, if I go to the base 2, how many numbers do we had? We had 2 numbers. If I go to base 3, how many numbers do we have? We had 3 numbers. Base 4, how many numbers? 4 numbers. Base 5, how many numbers? 5 numbers. Base 6, 6 numbers, and on and on and on, and that's right. So when we did the hexadecimal, we had how many numbers? We had 16 numbers. Let's count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Are you seeing that? So if I had base 20, I will have 20 numbers, but then it will be like G, H, G which is for 17, H which is for 18, I which is for what? And then what? The last number. You got it right. So that is it. That is it. After this number, so if I wanted to do after this base, if you go to base, let me use base 12 as an example, right? So for base 12, let me move this up a little bit. Base 12. So if I had base 12, I'll say 0. Let me come in. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? 8. So just like in our base 10, right, we add our building blocks, which was 0 to 9. In base 11, our building blocks, our A to Z that we used to combine to form other numbers, is from 0 to what? To A. So if I wanted to continue counting, just like if I wanted to continue counting in base 10, I'll now be adding 1, 1, 1. I'll say 10, 11, 12, right? But in this case too, I'll be adding 1, 1, 1 to all of these buildings. So to all of these building blocks. So if I wanted to do that, right, what would that be? That would be 1, 0, Abi, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, Abi, then 1A, right? So I've gotten up to 1A. If I want to continue counting again in base 11, right? I mean, isn't it better that we don't even use any other base apart from base 10 to count? I mean, these are one of them. Imagine us doing 1A, 1B, 1C. Right, so we'll continue again. If you want to keep counting, just like you'll be counting like 25, 26, but in this case I will say what? 20, 21, 22, all the way down to 2A. Does that make sense? And we can see. So let me see. There are some online tools, right, that you can use to convert. So you can see convert base 11 to base 10. Let's click on that. Let's see what 2A is. Let me see. Let's see what 2A is. Let's see what this 2A is in base 10. So if I say what is 2A, you can see 2A in base 11 is number 32 in what? In base 10. So I'll just do one last example, right? What is the example about? So if I was working in base 16, right? If I was working in base 16, let's see. If I was working in base 16, I would say, I'll do my normal 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Then when I reach here, I need how many numbers? So now I have 10 numbers, right? 10, 0 to 9, right? Inclusive. I need like 6 more numbers to be able to have that count of 16, right? So I will add. Now I cannot add any other. I mean, all these zeros and ones are the building blocks, right? Then that means I have to go to the alphabet. I have to add A, B, C, D, E, F, right? And this is like what we discussed the previous time. So if I wanted to continue counting in base 16, right, I will now say what? 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, 1 8, 1 9, what? 1A, 1B, 1C, 1D, 1E, 1F, and on and on and on and on like that. So if you ask, let's see, if you ask what is 1F in base, this is base 16, right? So let me just, this is base 11. So okay, so I think there should be, yes, convert X to decimal, right? So X is hexadecimal. Great. So let me, what was that number that I was trying to say? 1F, right? Let me see. So if I say convert 1F to hexadecimal, that is number what? Number 31. And let's count to actually be sure that is actually correct. So this is from 0 to 9. This would be number 1 in our decimal. No, this will be number 0 in our decimal, number 1, number 2, number 3, up to this point. This is meant to be number 10 in decimal. Number 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So you can see that in decimal, number 31 is what? 1F. Let me put the F so that it will appear very, very well, right? 1F is number 31. 1F in hexadecimal is number 31 in what? In decimal. Does that make sense? Decimal is base 10. So 1F in base 16 is what? 31 in base what? In base 10. Does that make sense? Great. Remember, if you have any question, if you need any further clarification, please drop a comment under the video, right? I'll personally take time to attend to every comment of such nature. Are we good? So now that we already know the different type of bases and how to relate with the bases, right, we can just continue further and see if there is anything that is actually new, right? We've talked about the different type of bases, right? So now the last part that we're going to be discussing is how to show the base, right? So look at something. If I write a number 1A, right, how would this person know that this 1A is not from base 11, or it's not from base 12, or it's not from base 13? Right, that is the part that we want to know. Let's find out. So it says that we should put the base in the lower right of after the number, right? So you can see this is like, if the person sees this person, know that this person is actually working in what? In base 2. It's not working, it's not 110. This is 110 in base 2, not 110 in base 10. If it says number, it knows that the person is working in what? Base 8. This 314 is in base what? Base 8. Right, same thing as this is in what? Base 7. So if I wanted to write this 1A and I wanted it in base 11, right, I'll just come here and say what? 1 1 under it. Do you get? So if I was working 1F, which is in base 16, right, I'll just say 1F and 16 under it. Summary, right? We discuss what are bases, right? And base number base, right? Ways at which you count numbers. I'm talking about different type of bases: base 10, base 11, base 12, base 2, right? We talk about different type of bases, and we said the building blocks of all these bases are numbers and alphabets. So the building block of numbers are from number 0 to 9. If, like in the case of hexadecimal, we need extra things to be able to represent the positions, we'll go to the alphabetical characters like A, B, C, D, E, F, right? So the building block for a base 16 element is from 0 to F, right? If I now still need to count further, right, then I'll be saying what? 1 0, 1 2, 1 3, maybe 1A, 1B, 1C, 1D, 1F. If I want to still count further, I'll say 2 0, just like combining things together. We also talked on how to show the base, right? We show the base by putting the base at the lower right after the number. And with this, I've actually come to the introduction to number bases. The next time we meet, right, or in the next video, right, we'll be talking more on how to really convert from one base to another base, right? You know, in this case, we use an online converter, but we'll now have, because I mean, in your WAEC, if this comes out, convert from base 3 to base 5, right, you won't have the luxury of having an online website to actually check, right? So we'll see how we convert from one base to another. See you guys in the next video. Don't forget to like, to comment, to subscribe to our channel, please, right? Thank you guys for watching.